Hello everyone, welcome back to Solid Geometry series. Today I have a very exciting problem for you all. Here it is. Let ABC, A prime, B prime, C prime be an oblique prism with triangular bases ABC and A prime, B prime, C prime. Let E and F be the midpoints of AC and A prime, B prime respectively. A. Prove that EF is parallel to the plane BC, C prime, B prime. B. Let CF intersects plane AC prime B at I. Prove that I is the midpoint of CF. Feel free to pause the video if you want to give it a try, otherwise stay tuned for the solution. Part A. Let D be the midpoint of B prime C prime. Then clearly FD is the midsegment in triangle A prime, B prime, C prime. So we have FD is parallel to A prime, C prime, which is parallel to EC. In addition, we have FD is equal to 1/2 of A prime, C prime, which is equal to 1/2 of AC, which is equal to EC. But since FD is parallel to EC, and FD is equal to EC. Therefore, quadrilateral EFDC is a parallelogram. Thus, EF is parallel to DC, which is a line in the plane BC, C prime, B prime. Consequently, EF is parallel to the plane BC, C prime, B prime. And that is it for part A. Moving on to part B. Let G be the midpoint of AB. Then FG is parallel to C prime C, and FG is equal to C prime C. As such, FG C prime is a parallelogram. Therefore, G, I, and C prime are collinear. Note that G, C prime lies in the plane A, C prime, B. As such, CF intersects plane A, C prime, B is the same as CF intersects G, C prime at I. But by property of parallelograms, we know that the two diagonals intersect each other at the midpoint. Thus, IF equal to IC, which means that I is the midpoint of CF. And that is it for part B. So that's all for this video. I'll see you all in the next video. Thanks. Bye-bye.